Alright guys, we are going to talk about atomic number and mass as well as isotopes today. We're going to go ahead and get started here. First off, the atomic number of an element is determined by the number of protons in the nucleus. Okay, so this is a pretty important part. Atomic number. The atomic number is the same as the number of protons. So if you look here, sodium has an atomic number of 11. Average mass of 22.99. So we know, because the atomic number is 11, we know that there are 11 protons for sodium. Okay, now this is important. As long as the element is sodium, it will always have 11 protons no matter what. That cannot change. The identity of the atom is based upon the number of protons. The mass, so the atomic mass, is the sum of protons and neutrons in the nucleus. So mass is the number of protons plus neutrons. Okay, because remember, the relative mass 1 to 1, the number of protons, number of neutrons combined is mass. Atoms have a neutral or a zero overall charge, so they must have the same number of protons and electrons. So the proton number is equal to the electron number. Now let's go ahead and work these out with sodium. For sodium, we know we have 11 protons and we have an average mass of 22.99. So we're going to go ahead and round that to 23. If the mass is 23, there are 11 protons. What we can do is solve for the number of neutrons here. Subtract out 11 from both sides. That'll leave us here with just neutrons, and it'll give us 12 of those neutrons. Then lastly, to find the electrons, remember, we had 11 protons, so we must have 11 electrons. The periodic table is organized in increasing order of atomic number. Okay, so as you look here, you notice element 1, 1 proton, element 2, 2 protons, 3, 4, 5, 6, and so moving left to right and then top to bottom, this is how the periodic table is organized by the atomic number, the number of protons. Elements having the same number of protons but a different number of neutrons are called isotopes. Okay? So an example of that would be if you have silver, let's say. So silver has an average mass of 107.87, which means it's likely that silver has a 107 and it has a 108 massed isotope. Now because it's silver, right, the identity of silver is based on the number of protons. There are 47 protons per silver. So in isotope notation, this is how we would read that. This would be called silver 107. This would be called silver 108. Now another trend is that mass will generally increase, with atomic number. So moving from left to right, you see 40, 44, 47, 50, 52. So as the atomic number increases, so then does the mass. But just be aware, this can be thrown off just a little bit based upon some weird specific instances based on the number of neutrons. So this is one example of that. Cobalt 58.93, nickel 58.69. So the mass goes down, but you notice it's 27 to 28 for atomic number. So the atomic number actually goes up. This also occurs with thorium-2 protactinium. And actually several of the heavy metals do this because they have various ratios of protons to neutrons. Now let's go ahead and practice these. So what we're going to do, I'll give you a second to pause this. Go ahead and pause it. I'll assume that you've paused it. Now let's work these out. So right here, we're going to order calcium, magnesium, cobalt, and nickel in terms of increasing mass. So we want to go increasing. We want to go low to high mass, increasing. If we look down here, we notice calcium is 40.08, magnesium 24.09, 58.31. Cobalt here, 58.93. And nickel, 58.69. So if I'm going to put these in order from lowest to highest, we're going to see that it will start with magnesium. After magnesium, the next lowest is calcium. And then we see that nickel is actually smaller than the cobalt, so nickel, and then lastly cobalt. Problem 2, we're going to order phosphorus, oxygen, magnesium, and titanium in terms of decreasing. So decreasing means we're going to go from high to low. Decreasing atomic number. So we'll see here phosphorus has an atomic number of 15. So we go 15. Oxygen has 8. Magnesium is a 12. And titanium, 22. So we want these in decreasing, so high to low. We're going to start with titanium as our high, and then phosphorus, followed by magnesium, and finishing here with oxygen. I want you now to write the isotope symbols for carbon 12, 13, and 14. Okay, so this was like the silver that we saw before. Because it's carbon, the symbol is C. 12 indicates the mass, so we write that above. So that can be written as carbon 12, or more specifically, again, because it's carbon, it has 6 protons, so the atomic number is 6. This is the standard isotope notation. Carbon 13 would be like this, and carbon 14 like so. Now go ahead and pause this video again, work these out, complete the table, and then I will go ahead and work this out. So first off, phosphorus. We see that phosphorus has 15 protons. We know that the number of protons is equal to the number of electrons, so 15 and 15. So again, proton number is equal to electron number. The atomic number is also the same as the number of protons, so proton number is equal to the atomic number. That has to be 15 as well. Lastly, the mass number, and if you recall, mass is the protons plus the neutrons. So you see here 15 plus 16 gives a mass of 31. Now aluminum is showing with 13 electrons and a mass of 27. So because I know I have 13 electrons, protons equals electrons, I must have 13 protons. Because protons is the same as atomic number, I also have 13 as the atomic number. And lastly, the neutrons are going to be the mass minus the protons. So 27 minus 13 should give us 14 neutrons. Now lastly, I have an unknown element. We're going to identify it based on the neutrons and the atomic number. Now again, atomic number is the same as protons, so I have 47 protons. Electrons are the same as protons, so there are 47 electrons. And the mass number, mass again is protons plus neutrons. So neutrons are 61 plus 47 gives 108. So we find the identity is based upon the atomic number, the number of protons. 47 protons means atomic number 47, which we identify as our silver. So this silver. All right. Hope that was good for you guys, and we'll catch you next time.